Just after 10 o'clock on this Sunday morning. Welcome to a live broadcast here at WCNC Plus and streaming on the Carolina Weather Group. I'm James Brierton, weather producer. And as you just saw this morning with meteorologist Brittany Van Voorhees on WCNC Charlotte, NASA is undertaking a big mission this morning to land asteroid samples that they collected from the asteroid Bennu. It's all part of the OSIRIS-REx mission. Earlier this morning, the spacecraft and the sample separated. And in the course of the next hour and change, we're going to be watching live as that sample returns to Earth. Joining me this morning is Candace Jordan from the Scheele Museum in Gastonia. She'll be walking us through what we're going to be seeing here and more about what you can learn about this mission and other fun science things at their museum there just to the west of Gastonia. And we also have Tony Rice, NASA ambassador from the greater Raleigh area. Tony, good morning to you.
Good morning.
And we'll have meteorologist Brittany Van Voorhees from WCNC Charlotte coming along here just in the next few minutes or so. It's just past the 10 o'clock hour now, and we can walk people through a little bit of the overview of what we can expect. This mission launched on September 8th, 2016, collected samples on October 20th, 2020, and began its return to Earth flight on May 10th, 2021. So this has been literally years in the making. And Candace, let me ask you as we get going this morning, what makes you so excited about this? I know you personally, and you have been talking to me about this for years now, and the day is finally here.
It's finally here. This is so exciting because we're literally going to have a piece of an asteroid that scientists can go and study. And that is so cool. You know, we're not relying on, just haphazard meteorites that we just luckily enough find, or, we've got like the lunar samples that we collected from the Apollo era, but really, having a controlled study that we can look at and really dig into the science of is absolutely amazing. And like you said, it's been years in the making. And today we're finally going to get those samples back. And all the scientists that are going to be in the process of studying this material are just elated for the 11 o'clock hour to happen.
Yes, absolutely. And we are looking live at their control facility here. I noticed on their big monitor in the last few minutes that we were talking, it appears to me, and I don't mean the sample return there on the big monitor. Let me ask you a vocabulary question, Candace. So it's the OSIRIS-REx mission. Mm-hmm. And they went to the asteroid Bennu. But now the spacecraft has diverted off to Earth. And we'll talk a little bit later about where it's going next. What do we call the object that is carrying the capsule and about to return to Earth? What is my proper terminology for this thing that is flying through the atmosphere here shortly?
I think it's called an IFO, an identified flying object.
Oh, I see what you did there. Okay. I might just refer to it as the capsule.
Yeah,
right?
I think the capsule is probably what you're going to hear the most of.
Yeah, and we'll take a look here at the NASA TV map. You can see they're going to be touching down in Utah in the next 49 and a half minutes or so. We do have some entry times I can share with you here, which is that at 6:42 a.m. Eastern time this morning is when the capsule detached from the spacecraft. At 10:42 a.m. this morning, still to come, is when they'll begin their entry flight. And then we're expecting them to touch down at about 10:55 a.m. or so. So all of that will be coming your way here in the next hour or so. If you're watching with us on Facebook or YouTube or any of those platforms where you can ask comments, you're welcome to do that throughout the broadcast. And we'll try to answer as many of them as we can. Candace, why Bennu? Why did they pick, of all of the asteroids in space, why did they set their sights on that particular one?
Yeah, so first and foremost, this one here is relatively close to Earth. Space is a vast distance here. We don't want to go all the way out past Pluto to grab one of these. So we're grabbing one in the closer asteroid belt, so the one kind of between Mars and Jupiter. So proximity is is a very likely high key that we're looking at. Also, this one here has different elements that they're wanting to look at. So, could have some carbon, some other elements that are decent for studying, and that's what they're hoping to do is literally take some of this, kind of investigate, how did our solar system form. These asteroids can really help us tell the building blocks of our solar system, and so that's one thing that we're trying to basically piece together. It's think of astronomy like looking in the past and trying to figure out where we come from. It's like a big jigsaw puzzle. So this piece that we're getting here from asteroid Bennu is literally going to help, you know, fit another puzzle piece in there, and hopefully we start getting a clearer picture. So that's why we chose Bennu. It's a promising candidate. It was a large enough asteroid, so that was another thing that we wanted to do. Um, and I just want to commend all the scientists that put the work into this. For any of the kids out there that are watching, and you're like, what can I do with science and math? You hear about STEM careers all the time. I want you to think about how much math was involved with this. This has been a mission going on since 2016, and they know that this capsule is going to land within about an 8.5 mile range in Utah desert. And think about that. That's years in the making, and we can pinpoint that location to like 8.5 miles with it going to an asteroid, booping an asteroid, coming back,
Booping.
and then, yeah, booping, that's a scientific term.
Yeah,
And
I
then,
think
like,
so.
launching the capsule this way. That's just amazing to me. Like, you can calculate that with math. So if there's any kids out there that really love math and science, just know, like, there are some really cool careers out there.
There really are. We're going to bring in Brittany Van Voorhees and Tony Rice in just a moment. We're watching several feeds that are coming in from NASA TV. We're going to dip into them throughout the hour and provide you some of our own commentary as well, too. NASA TV's on the air. They have a reporter out at this remote site in Utah, and I want to just take a listen into what's happening out there this morning. We'll be back with you in just a moment.
Is standing at the forward edge of the vast landing zone where she joins us live now. Sophia,
thank you,
paint us a picture.
Lauren and Jim. Now, it is a bright and chilly morning, but the excitement certainly is rising. Now, let me give you a lay of the land of what is going to happen today. The sample return capsule is going to hit the top of the atmosphere at approximately 8:40. It will descend through our atmosphere for 13 minutes before touchdown. Once it does touch down, our team with the recovery team will go to the sample or the capsule and start that carefully rehearsed recovery process. Now, I am on the edge of the landing zone that we call the ellipse. It is a huge landing zone that is larger than the size of Rhode Island. And behind me are the helicopters that will be taking those recovery teams to the capsule once it lands. Now, these teams are prepped and ready to go. We're just waiting for that capsule to arrive. Back to you, Lauren.
Wow, Sophia, I think she has the best seat in the
Oh my
house.
God, take me there.
I want to go there. All right, let's get some quick facts about the OSIRIS-REx spacecraft.
All right, we will be listening in to NASA's coverage throughout the course of our broadcast here. We have Candace Jordan from the Shield Museum in Gastonia, welcoming in now Brittany Van Voorhees from WCNC Charlotte, and Tony Rice, NASA ambassador from the greater Raleigh area. Good morning to you all. Tony, we were starting to talk a few minutes ago, and I wanted to ask you this question here as people are getting familiar with OSIRIS-REx and what is going to unfold over the course of the next hour or so. The spacecraft itself that has been flying for years now, it's still up there in space. Where is it going from here after departing its capsule?
Oh, I knew you were going to ask that question. It's really of no use to us anymore. I'd have to double check what its disposal plan is, but it will likely either burn up in Earth's atmosphere or it will be put into a solar orbit and eventually deorbit somewhere. It served its job. Its main job was to provide kind of an Uber service, if you will, for this capsule that's returning here in just about a half hour's time. But it's just a transfer vehicle.
And I was reading a lot about how this is the first time the United States, the first time NASA has conducted collection of an asteroid samples from space, and now we're returning them to Earth. But I take it that maybe somebody else has done it before, since there seemed to be the descriptor on it the first time the U.S. has done it. Do you know offhand?
Yeah, so the European Space Agency has done some collection as well, and we learned a lot from that mission about how to go about collecting samples on this big space rock. Bennu is kind of special. It's a rubble style, a rubble pile style asteroid. So that made it a little bit easier to collect some of the asteroid materials. Previous asteroid collection missions have kind of bounced off of the asteroids. There's first every time we go out and do something like this, and the idea that the European Space Agency went with their mission was that we thought all asteroids were, about the consistency of, say, a charcoal briquette, and they were using a harpoon type of mechanism to attach to the asteroid to be able to gather some samples, and it kind of bounced off. These things are smaller than a planet, of course, but they do have gravity. The mission, the spacecraft that was collecting in that European Space Agency version, it eventually settled back down. They were able to collect their samples. But I should point out that this isn't the first time we've done something like this in NASA, and also not the first time that we've returned to the Utah test range, which is just west of Salt Lake City. This is a very similar capsule and kind of a similar approach to returning it as a mission that happened several years ago. And you can see a model of that spacecraft, which is the same capsule design that we're going to see here in a couple of minutes, up at the Air and Space Museum. We weren't going to an asteroid then. We were flying through the tail of a comet and gathering material from the comet's tail. The goal of both of those missions was very much the same, and that's looking at cometary material, looking at asteroidal material as the building blocks of the solar system. These are really some of the oldest things out there and can tell us so much about how our solar system was formed.
I want to show people here some NASA TV animations that are currently airing. These are animations of what has happened this morning, and here what will be happening ahead. 8:42 when the capsule enters the atmosphere, 8:43 when it experiences maximum heating. It'll then have to decelerate from 20,000 plus miles an hour, I think, if I remember correctly from my reading, Tony, before coming down in that Utah desert. And then what becomes of the capsule, Tony, once it lands in the Utah desert? How do they get it to safety before we contaminate it with Earth material?
Yeah, so you saw on the NASA video there the two helos sitting on the ground. They're going to go out and capture this thing. It's going to come down on parachutes, and we'll probably see that in the video here in a moment. Which is very different from how we attempted, I'll say, to bring back that cometary material. That cometary material, that particular mission, we tried to capture it with one of those helicopters, and we used some pilots, Hollywood pilots, basically, that have been using their helicopters to film movies. Didn't work out so well. The capsule did crash, but we were able to get some good samples out of it. This is going to be a little bit different. As you see, it's going to be on the chute. It'll come down on its own, and then those two helicopters will go out, gather up that capsule. We hope it's this general right here, and bring back about 8 ounces of asteroid material. The next stop will be the same facility that was used to intake the lunar material in Houston at the Johnson Space Center.
And I guess let me ask you this. I recently had the chance to bring my family to the visitor complex at Kennedy Space Center this summer, and there's a moon rock there. We've got samples aboard here from an asteroid. Where are these samples going, Tony? Is it someplace that people will be able to see and touch them?
These samples are going to go first to scientists. There was a very concerted effort to make sure that the samples that were brought back from the lunar missions, and there were many, many pounds of samples that were brought back for study, and also to do some of the things that you're talking about there. You're able to see a sample at the Kennedy Space Center. You can see samples up at the Air and Space Museum. There's several of them up there. There are several samples here in North Carolina. There is a lunar sample that's on display at the Museum of the Natural Sciences Museum in downtown Raleigh. Where I'm sitting in Raleigh right now, there are several samples not far away. The History Museum has one downtown. They don't have that on display. It's brought out from time to time. During the Apollo 11 anniversary, they put that on display as well. So you can see lunar samples right here in North Carolina. again, pounds and pounds of lunar samples versus 8 ounces of asteroidal samples. First and foremost, those samples are going to scientists for study.
Very cool. Very cool. Tony, thanks for being with us this morning. We'll check back in with you throughout the broadcast. Let me bring in Brittany Van Voorhees, meteorologist at WCNC Charlotte. Brittany, in just a moment, I'm still queuing up the tape. In just a moment, we're going to take a listen to the broadcast or the interview you recorded with NASA. I guess set that up for us. What did you learn in your conversation? And then we'll take a listen to it.
I think the biggest thing that I took away that I thought that was really interesting is that, and Tony kind of touched on this a little bit, is that even though we know that the start of our planet, was millions of years ago, there's still all these questions as to like where we came from, what certain things came from. And so I feel like a lot of times I hear like offhand comments from people about like why we're doing this and like why NASA's spending money on this. And I think this one was like a really good example as to why. The NASA expert that I spoke with, who's really, really, really informative, and of course I don't want to give it all away. This is a little bit of a spoiler, but talked a lot about really being excited about seeing the samples, and really he wanted to know specifically, like, because I asked him personally, like, is there something you're really looking forward to? And his answer was to see if there was any water in it. I know Tony mentioned a little bit ago that it was really hard and there was like an issue with bouncing off. So I'll be interested to see if like any of that has to do with the gravity versus, the consistency. But he said there's still so many questions about what the water comes from, not only on our Earth, but us as humans. So what is it, like 71% of our bodies and 71% of the Earth approximately is covered by water. So there's all these questions about like what our biggest life source really other than the sun came from. And I thought that was like a really interesting question that, the time that NASA's been around, that we're still kind of working on answering that question. So I thought that was a really interesting, I guess, perspective. Like, it just seems like such a tiny thing, but it could mean the biggest thing, humans.
Yeah, we got that tape queued up now. It aired this morning on WCNC Charlotte, Wake Up Charlotte Weekend Edition. So those of you watching on WCNC Plus, here it is again.
7 years ago, NASA's OSIRIS-REx mission blasted off to an asteroid named Bennu. Its mission to collect samples and return it to Earth. After traveling for nearly 3.9 billion miles, OSIRIS-REx is set to land back on Earth late Sunday morning. Here to discuss why this accomplishment is so meaningful to the scientific community is Tom Statler, program scientist for NASA's Planetary Science Division. Good morning, Tom.
Hey, good morning. We're really looking forward to this biggest return of extraterrestrial samples in over 50 years.
I mean, I'm excited, so I'm sure you're excited too. So, Tom, we know asteroids are small, rocky, dusty bodies. They orbit the sun. But why is studying them so important?
Because they're not just any old rock. They are leftover raw materials from the formation of our planets 4.5 billion years ago. And every asteroid is carrying a memory of a different part of the story of our solar system. We really want to understand the big questions about where we came from and what we are, how our Earth came to be the way it is, and what had to happen on the Earth for conditions to be right for life. That's why we're studying the asteroids, to understand that history.
So cool. So this is NASA's first ever asteroid sample return mission. Can you kind of walk us through the journey from maybe start to now this finish?
Sure. The robotic spacecraft that's OSIRIS-REx was launched from Cape Canaveral in 2016. It took about 1.5 years for it to match orbits and rendezvous with the asteroid Bennu. It went into orbit around Bennu and stayed there for about 2 years doing detailed mapping and remote instrument studies, spectra, colors, all kinds of things that you can do from a distance, and determined where the best place was to try and do the touch and go sample acquisition, which was done in 2020. Very briefly, the spacecraft settled down to the surface, extended an arm, and that touched the surface of the asteroid, collected the sample. It was stored in the sample return capsule. It's been 1.5 years now coming back, and Sunday morning that capsule is going to be released. We'll re-enter the Earth's atmosphere at a speed of almost 28,000 miles an hour, slow down abruptly, and parachute down to the desert in Utah. It's going to be picked up, made safe, and then the next day flown to our curation facility at Johnson Space Center in Houston, Texas, where everything will be made secure and the examination and study will begin.
Oh, so cool. So I know you said obviously life, specifically knowing where we came from, but is there anything specific, maybe you or maybe some of your co-scientists are really just excited to learn specifically about this mission?
About this asteroid, I want to know what the chemical composition is. I want to know how much water there is in it. This question of where did our water come from is just so compelling. The very, very early Earth would have been hot and molten. It would be hard for water to stay around. And so there's lines of evidence pointing to the idea that maybe asteroids were responsible for delivering the water to the Earth after it was cool. And so if our bodies we're 75% water. And so if the water in our bodies and the water in a child's tears can be traced to a black rock in space that crashed onto the Earth billions of years ago, that says something really amazing about ourselves and our relation to our planet and the cosmos. So I want to know about the water in that object.
I genuinely just got chills. That's actually really cool. Well, I'm really excited. I know our viewers are excited. I know you're excited. How can our viewers watch the capsule return if they want to?
Well, we're going to live stream the whole event free to the world. It's going to be on NASA TV and www.nasa.gov. You can follow on social media at NASA. The touchdown is going to be 10:55 a.m. Eastern Time in Utah. The broadcast starts at 10 a.m. Eastern Time, and hope we'll see everybody there.
And here we are, Brittany.
I know, I was about to say, I actually did you guys a shout out, and it was actually really funny. I don't know if Candace can hear me, but like for a second, I just had, you know how it is like when you're ad-libbing and you just like have a brain fart, and no, hopefully I can say fart on here.
Those are the type of things you can say on WCNC Plus.
Well, I would have said on TV too. But I was like, Candace Jordan, former TV meteorologist, works for this geo museum, great. Head of, I said, I think she's in charge of science education, maybe. All right, Tony Rice, NASA ambassador. I don't remember what her title is, but and then of course, James, I included you too. But I was like,
Nice.
Oh my gosh, what is happening to me?
I've kind of switched around a little bit, so yeah.
I was like, what? What's that? Every time I knew Tony is, I was like, NASA ambassador, NASA ambassador.
You get all those lanyards in the background when you're a NASA ambassador as well.
Yeah, exactly. You get to go all those cool
Right?
places.
Yeah. So Tony, while we were watching that, you sent me this screen share. This is a NASA plane that's out there in the Utah desert. What can we learn from this flight tracker?
So this is the WB-57. These are Vietnam-era aircraft. NASA has 3 of them. I think they might even be the only 3 that are left flying. There are 2 aircraft that can fly above, left flying, that can fly above 50,000 feet. This is one of them. The other one is the U-2, which NASA also has as well. We've seen some of those fly over North Carolina doing some weather research. But the WP-57 is a fantastic aircraft. It was a reconnaissance slash bomber back in the Vietnam War. But today NASA flies them for missions like this. It's a camera platform. So I expect we're going to see some images of the capsule on the chute as it flies down, as it lands there in the Utah desert. They're going to come from this aircraft right here. So this is going to give us a good indication of the trajectory that the capsule is going to take. And they got a landing area. They got an oval that they're aiming for. They always want to hit the center of that oval, but that's going to give us a good indication of where where that capsule is going to land. And those images that we're going to see, it's going to come live from this aircraft.
And I guess I don't know this for sure, but taking a look at their live mission control here, I'm guessing that's going to be one of the monitor displays there, either on the left-hand side or in that big box. As we await, we should expect that entry to happen at about 10:42 this morning, ahead of the touchdown at 10:55. So a few more minutes, I think, until we start being able to track this thing coming live through the atmosphere. Candace, let me bring you back in. What do you think, as an educator there at the museum, what does missions like this allow you to do in your day job when you're visiting with kids and parents and the public?
Yeah, so one thing that I love to bring in, I think you heard me talk about earlier, is just like the different careers. I love trying to inspire new generations, because literally the kids that come in our museum, you never know, they may be the next person to go to the moon or colonize Mars. Like, they're all very capable of that. So, being able to bring this real-time mission to the museum and allow people to, we have like a 3D model of Bennu that we 3D printed. So, they can like touch the asteroid. We can, show them, okay, this is like where it collected the sample. The sample is like, I think about 8.8 ounces, which I think is like 250 grams, if I remember from NASA correctly. So that's like 250 paper clips, so allow kids to hold 250 paper clips and be like, that's all that they got. But that's a tremendous amount. And they're going to be able to learn so much from this. You don't have to collect, a ton of material to get a lot of knowledge out of it. So just being able to tell them like, you can use your resources really wisely and show them how this really does connect to everyday life. It's not just something that we do, just because we're like, we want to collect an asteroid sample and somebody was like, cool, let's do it. There's real world applications behind this. So it's really nice to bring that to the local community, because sometimes, it does feel like, oh, well, this is happening in the US, but like it doesn't pertain to me at all. So bringing it down to our local community is always really nice.
Candice, you'll be happy to know I double checked your math. It is 250 grams and 8.8 ounces. So clearly you had your coffee this morning, because you were right on top of that, which was good.
Did my homework, guys. You should do it too.
Let's listen back into NASA TV. They have an update out there from the facility in Utah.
Oh boy, that's going to be so cool. All right, Sophia is standing at the forward edge of the recovery zone with an update. Take it away, Sophia.
All right, thank you, Lauren. We are under 20 minutes away from EDL. That is entry, descent, and landing. And I don't think there's anyone here on planet Earth who has anticipated this day more than the principal investigator of the mission, Dante Loretta. Thank you for giving us time here today.
My pleasure. It's great to be here.
All right, so you are here on Wig Mountain because you are on the recovery team.
That's right.
Can you walk us through what you're going to be doing today?
So I'm part of the environmental sampling group. From day one, this mission has paid attention to keeping that sample pristine. And we're going to come down. We had some rain on Thursday. Most likely we're going to be encountering mud out there. We're also interested in the air quality and any water that might be standing, just so in the very rare event that any of that material somehow comes into contact with the sample, we have a record of it and it won't compromise our science.
Oh, wonderful. And I think one of the really exciting things about a mission like this, especially with you working with the University of Arizona, is that you're partnering with educational institutions. So can you talk a little bit about the legacy that a mission like this has?
Yeah, thank you. I'm a professor at the University of Arizona in the Lunar and Planetary Laboratory, and our history goes all the way back to the Apollo missions. The founder of our lab, Gerard Kuiper, mapped the moon, helped pick the Apollo landing sites and the Surveyor landing sites, and we have been involved in every major NASA planetary mission since then. And really the best part of having a university lead a program like this is that it's a great training ground for the next generation. I've been on this program almost 20 years, and I've watched multiple generations of students grow up, become professionals, either join the team. We always take our team members on board when we need to fill roles, or off into other careers in aerospace engineering, science, and many other disciplines.
It's really great to foster those incredible questions about our universe.
Absolutely.
And I know that you need to get back to your team to go on that recovery process.
Big moment's almost here.
Yeah, so thank you so much for joining us, and best of luck out there today.
Thank you.
All right.
We'll talk a little bit more about those aircraft behind him in just a moment. But Brittany, let me bring you in, meteorologist WCNC Charlotte. They talked about the weather. How's the weather looking out there today?
It doesn't look too bad. I was looking at the temperature especially because they're all bundled up. Obviously, there looks like in somewhat of like a valley. So, of course, we know that, warm air rises, cold air settles closer. So the official temperature readings around that area in the low 50s. I'm sure, though, a few spots in the upper 40s, especially just based on where they are. So you know how it is, especially when you're in the shade, it can feel colder than that. So that's not surprising. What I was looking at was the wind. I mean, obviously, an aircraft that's coming at that kind of trajectory, it doesn't seem like it seems like you would need more of a significant wind to kind of impact it. It's out of the southeast at about 7 miles per hour right now, so I wouldn't anticipate any issues with that. But, he had mentioned rain. Of course, I'm sure that they prepare for that. They kind of know that as they go collect, they know that rain, especially in Utah, they don't get a ton of it throughout the year. So, of course, they kind of have to prepare for that and the opportunity that they could even see rain this morning. But it doesn't look like that's going to be the case. I really think that they probably couldn't ask for better weather for some kind of landing touchdown like this, because of the fact that they're seeing completely clear skies, light wind 5 to 7, and temperatures in the 50s, highs in the 70s today. Honestly, we probably wish we had that in the Carolinas, but I wouldn't think that they would have any issues weather-wise.
I'm just happy to see the sun today after the tropical storm impacts yesterday. Yes.
Yeah, and Candace, I really liked what you were saying earlier about like the education and stuff like that. I think that I'm sure you saw the same thing, whenever you went to school talks, especially when you were in TV. But I think that's like a big thing, especially when we see little kids. They're like, well, I like math and science, but I'm not very good at it. And like, I don't know what I would do. But, you can tell them like, I didn't get an A+ in calculus 3. So there's
right.
So I think it's like you can do things and like kind of foster that creativity and also that interest in math and science. So hopefully it does it too.
I was gonna say, I love taking these like STEM careers, because when you think of like astronomy, like the first thing you think of is an astronaut. And I'm like, there are literally just a handful of people that get to be an astronaut, but there are a multitude of people that help get those astronauts where they are, So if you don't want to be in a pressurized suit on the top of a rocket blasting off into space, you could be the one who creates the rocket, who calculates the trajectory, who collects the samples. So there's so many jobs out there that can fulfill that astronomy role, or whatever branch you really want to go into. I think that was one thing that I wish I would have a little more exposure to growing up, and so that's something that I want to bring to the next generation, is just you have kind of like those highlight careers in specific branches of science, but like there are so many more people that make those highlight careers highlighted. And so you could be one of those really cool roles that collects a sample or studies it or does whatever.
Well, let's bring Tony back into the conversation, because Tony, you've got a day job, but you get to be a NASA ambassador too.
I do, and I get to have a lot of the same kind of conversations that she's talking about there with kids. And the question always comes up, and it's natural: what does it take to be an astronaut? But as you mentioned, there's so many other jobs that are available in NASA. There's so many other jobs that make it possible to be an astronaut. Everything literally up to and including firefighters, police officers. You name a job in a small town, and it probably exists within NASA, because it takes that many people to pull these kind of incredible things off. So when somebody says, I want to work for NASA, the question is, well, what do you want to do? It's not just astronauts that are out there. And I kind of look at it the same way we look at, maybe the NFL. Kids say they want to play football. They want to be professional football players. It's a really low probability that any given kid is going to make it into the NFL. Also a very low probability that you're going to make it to be an astronaut. But there's so many other careers that are out there that can help support those astronauts. And as we see here, this is not a crewed mission. This is a robotic mission that went out there and is going to gather some incredible knowledge that is going to pay benefits forever. Think about those lunar samples. We are still today studying those lunar samples. There are rocks that we have not cracked into yet because they purposely saved some of that material, knowing that technology is going to advance over the years. 50 years later, we're still learning things from those lunar samples. We've only got 8 ounces, almost 9 ounces of asteroid material to play with here. So the chances or the opportunity to save some of that is a little bit less, but we're going to continue learning from this mission for many, many years to come.
We're beginning to see on our control room feed what might be that aircraft signal you were talking about a little bit earlier, Tony. And I'm also going to pop back up the flight tracker because there was something else I think you wanted to point out here.
Yeah, this is so cool. So when we think about NASA's involvement here, but there's so many people involved in pulling something like this off. I was just reading the document this morning that was the plan for this that was submitted by the Federal Aviation Administration. So the FAA is very involved in this as well. You see all those aircraft around there? They're still flying. And the Salt Lake City Airport, you can see there on the right-hand side to the the lower part of the Great Salt Lake. There's still operations going on there. There's what's called a NOTAM, Notice to Airmen, that was issued for this time, and it's a space operation. The same things happens when we have launches. The same thing happens when we have landings that come back. The SpaceX spacecraft that come back permanently to the Gulf of Mexico, which that WB-57 we're looking at right now, that's also the same aircraft that will get us those gorgeous pictures of the SpaceX capsules coming back through. But it takes this great coordination to make sure that something like this can be pulled off at all, and definitely pulled off safely. So it's kind of cool to see all those aircraft coming and going while we've got something coming in at Mach 10 from literally outer space.
It's going to be pretty incredible, the moments coming up here in just the next few minutes. Candace, do you have anything planned for the Shield Museum after we get these samples back?
Yeah, so the Shield Museum opens up at 1 o'clock, and from 1 to 4, I'm going to be out there just talking to people about this. We're going to have our 3D print of the asteroid Bennu, so you can kind of, fake touch an asteroid. I'll have a small meteorite out there that you guys can get your hands on, so you can say you've touched something out of this world. And just really come bring your questions, and we'll just chat. Just really exposing the public to something that happened really this morning that was super cool.
We are expecting the capsule containing those 250 grams of Bennu asteroid samples to enter the Earth's atmosphere at 10:42 this morning. I had a touchdown out there in Utah at 10:55. It's 8.8 ounces. Again, if you're just joining us, this is going to be the conclusion of a multi-year mission, the first by the United States and NASA to go and collect samples from an asteroid flying through space. It all began when the rocket took off in 2016 on September 8th. Collected those samples in 2020 and started on its return trip home in 2021. I can't think of anything, really that many things from the year 2021 that I am still doing, but these scientists have been working hard on this multi-year mission. Tony, I don't know offhand if you know if there are any challenges that they had to overcome during the mission or ahead of the mission that they had a plan for that made this mission extra challenging.
Not off the top of my head. I know that there are always contingencies that are in place. And looking at the flight plan this morning, I noticed that there was a possibility of a correction maneuver that was available, basically to put the parent spacecraft, the mothership, if you will, into the right position to be able to return it properly to the Utah proving grounds. And I don't think they took advantage of that, which is a testament to how well the mission went in terms of getting it into the right position. They also had a number of contingencies that were available should weather be a problem in Utah. They could have brought this back to the White Sands, New Mexico range as well, which we have also landed the space shuttle. But it looks like this one was great. And if you switch back to the view of the aircraft there, I see that you see the helicopter that just launched in the Utah Proving Ground? Yeah, so it looks like they just launched one of the helicopters it's one of the Airbus helicopters, which I believe that particular one normally lives in Florida and is used for launch operations there. So right now we've got 3 NASA aircraft airborne. We've got the Airbus helicopter, we've got the WB-57, and if you look down to the left of the WB-57, the purple aircraft, that's one of NASA's Gulfstreams that normally lives at the Johnson Space Center. I'm not sure if that is the one that was used as a trainer for landing the space shuttle, but it might be. So we got a number of NASA aircraft in the air right now, which means we're really close to the capsule coming back.
I had a chance to visit Kennedy Space Center. You mentioned that some of these aircraft might be based out of there, and they have some really awesome air support. That these things are multifaceted. They're going to give us live pictures here on television. They're going to allow them to collect even higher resolution, maybe even ultra high resolution video to help with analyzing the flight trajectory and anything that might happen during the entry. Now, this is not something that they just do unrehearsed. This is something that has lots of coordination, and they actually have done a full rehearsal of this. And I'm going to go ahead and pop up on the screen now some pictures of what they did during the rehearsal out there in the Utah area. And I've pulled up some of the pictures, Tony, that really allow us to see some of those helicopters. That does certainly look like the one that they have out there at Kennedy. And you can see they have multiple helicopters that are going to be in the air. Now, they have a fairly good idea of where this sample is going to come down, but I think there is some margin to it. So while they are able to continue flights out of Salt Lake City, which is pretty incredible, they have probably, Tony, I would imagine, just like with a mission coming home from the International Space Station, they keep these aircraft back a short little distance, and then they come rushing in the moments after touchdown. That's probably kind of what we're going to see here?
Yeah, definitely. And if Brittany's still on, if you could give us some more information about the prevailing winds, because I noticed that all of the aircraft that are coming out of Salt Lake are heading just about due south, which is a little bit unusual for them. So I think they're giving a nice wide berth to the UTTR and the proving grounds there. This isn't like a launch where we can wave it off if there's an aircraft that strays into the box.
It's a really good point.
That capsule's coming whether we like it or not. But yeah, you hit the nail on the head. We're going to learn the reason these images are up there. It's cool to see them coming live. So really. And
here they are, things. I believe.
There we go. That's from the WB-57. Really hot things show up on these kind of images really, really well. So we're going to be able to watch that. But it's not just about these kind of live images there. We're going to learn so much about returning something to Earth, whether it is a capsule like this. A capsule's about a yard wide, about 2.5 feet deep, and weighs about 100 pounds. We're going to be able to apply that to crude missions as well. So that's the reason this imaging is there, is we learn so much from it. So real quick, what you're seeing here, there's an ablative heat shield on the bottom of that capsule, technology that dates back to the Apollo, and even farther back from that. That is helping absorb some of that heat. And this is friction in the atmosphere as this thing comes through, again at Mach 10.5. It's helping slow it down. Actually pulls most of that speed off is through that heat shield. Then the rest of that speed is going to be pulled off by a parachute that I want to say is about 20, 21 feet wide, so pretty good sized parachute. We'll probably be able to see that here as well. But that stream you're seeing coming off of there, that's real. That's the heat shield being burned away and streaming off behind the capsule.
From the rehearsal, and this is the rehearsal dummy, if you will, this is what the capsule more or less looks like. And you can see that heat shield that Tony just referred to. It reminds me, Tony, of almost a model version of what they would use to bring astronauts home from the space station or from any other mission from space, with that kind of bezeled nose cone.
The physics are the same, whether we're talking about a capsule that has 3 people on board or more. As it is for this kind of an uncrewed mission, where we're talking about a 100-pound capsule that's got 8 or 9 ounces of asteroid on board.
We are looking live here at NASA provided images as we await the return of this sample, a multi-year mission that will be coming to a big milestone here in the next few minutes as they recenter those pictures. We'll also show you the flight tracker that we've been watching. So we're out here at the Utah Testing and Training Range just outside of Salt Lake City. You can see some of the NASA aircraft here over this closed airspace. Tony, you asked a few minutes ago about the winds. The winds in Salt Lake right now are southeast at 5 miles an hour. So they are moderately light as we await here in the next few minutes for the pictures to get a little bit clearer. We are just at the beginning window of time here where the sample is beginning to make its way through the atmosphere, and we expect it to be on the ground at about 10:55. As somebody who dabbles in photography, I do find it amusing that in the top right, it says zoom 100. You cannot zoom any further. We've all been there where you just want a little bit more zoom.
It's like, just crank it up to 11. That's all. Just give it a little bit more.
Just a little bit more. Although, of course, this is probably more zoom than any of us have ever used in our lives, because this is going to be a very high power camera. Candace, like we mentioned at the top of the broadcast, you have been waiting a long time for this day. What is going through your mind right now?
Oh, well, we were just talking about the heat shields, and one thing that I find fascinating, these heat shields can get thousands of degrees because they're encountering the friction of the atmosphere. So if you want to play along at home, put your hands together. That's kind of what happens now. Rub your hands together really, really fast, and you'll feel that your hands do get pretty warm. And like after a while, you kind of have to stop because your hands get a little too warm. These heat shields, as it encounters the friction of the atmosphere, it hits all those air molecules. It's creating that friction, and it's getting up to like a couple of thousand degrees. But I think the coolest thing is that by the time it gets to ground, it's not thousands of degrees anymore. Like, it actually cools off pretty quickly.
Yeah, it does take several minutes, but over the course of the grand scheme, it is slowing down very, very quickly. I know based on the earlier animation we saw, we're going to be coming into kind of those maximum heat, maximum Gs here in probably about this time. We can now see the capsule as a faint black dot streaking across the sky. It really does look like it is moving incredibly quickly, which of course it is. I had a sheet here a minute ago, and I'm pretty sure, maybe Tony can correct me if I'm wrong, it started its entry at 27,000 miles an hour. And will have to obviously come to an abrupt halt, all things considered, before it reaches the ground out there in Utah. And then after it does reach the ground, Tony, they're gonna hoist it away and bring it to a safe room or a clean room.
It will definitely be handled by a clean room down in Houston. They will not open the capsule in Utah. It's kept pristine where it is, and it will be taken to the Lunar sample processing facility in Houston, where it will be handled absolutely in a clean room, possibly in a vacuum. I've not seen the details on that, but that is the idea, that those samples are kept absolutely pristine because we want to see things that were in space and not things that were on Earth. Again, a lot was learned during the Apollo era about doing that. And a couple of numbers for you. It enters the box, the area of the Utah Proving Range, at about 150,000 feet. The parachute's going to deploy at 16,400 feet. So
we just got the main parachute, it looks like.
Okay. Yeah. So we passed that flight level. And for comparison, the WB-57 that we're seeing these images from is flying at 45,000 feet. So that's why we're looking down on it.
Oh, wow. So it's below the aircraft now, below this high altitude aircraft. Wow. Let's listen in real fast here to some of the commentary from NASA TV, get some of their perspective.
The team there could potentially have a wonderful view momentarily as well. We'll continue to descend. Our next altitude descent will be at about 4,000 feet. Just a few minutes away from getting that sample from the other side of the solar system, from the surface of asteroid Bennu at sample site Nightingale, to the rug. Looks like winds are relatively low. Not a lot of rocking back and forth. Those parachutes seem to be perfectly smooth coming down, that parachute there. Continuing to descend. The slight little bit of tilt back and forth of our SRC as it comes to its resting velocity of 11 miles per hour as it makes that final descent.
Tony, I can't help but notice that the surface of Utah, I can see now why they do so many space training missions out there, because it does almost look like the surface of the moon or the surface of Mars.
Arizona and Utah have been good to us in providing some great analogs for lunar or even Martian exploration.
I know it wasn't too long ago that they were taking the, forgive me, I can't think of the name of it, but the vehicle that the Artemis crew will be driving around on the lunar surface. They've been test driving it out there in the desert.
Yeah, they actually got a little space outside some of the main buildings of the Johnson Space Center too, where they do some of that.
We got about
I'm just blown away.
Over 5 minutes here. Go ahead, Candace.
I was gonna say, I'm just blown away. We're going from like 27,500 miles an hour down to 11.
Yeah.
Like,
talk about like screeching brakes.
Right?
And you know what? This is relatively easy compared to, we talk about how these things inform other missions. Well, other missions have informed this as well. This is relatively easy compared to getting spacecraft down on Mars. Very, very similar challenges, but it's even more challenging there because the atmosphere is so thin. The parachutes have to be so much bigger, but it's the same thing. We got to slow down from 37,000 miles an hour down to basically zero, and do it without creating a crater in the process, without turning our precious spacecraft into parts strewn across the desert floor. So you're right. This is, most of that speed is being pulled off by the heat shield, and now the parachute. It's really not doing a whole lot of decelerating right now. The parachute's doing.
Got some comms here. We'll listen into real fast. Sorry, Tony.
That is Phenomenal. Let's see that view here from that first helicopter. They've got visual on the sample return capsule under parachute, that orange creamsicle color parachute, really bright in the morning light over the Utah Test and Training Range. A great view of the SRC.
All right, so we heard some radio communications, which I think were an indication that the helicopter now have some visual. Tony, your last comment made me think, is it easier to land on a planet like Mars that has less atmosphere, or is it easier to land on our planet, which might have more atmosphere, but we're more familiar with it?
It is significantly easier to land on the Earth than it is to land on Mars. Thin atmosphere means that there's enough there that you got to deal with it. The heating, the same kind of heating we see as we come into the Earth's atmosphere. This is an absolutely good test to show how that heating works. The same thing, it's friction. But there's so little that it's hard to really make a parachute work right. But the bigger thing is, and you pointed it out there, that we're more familiar with Earth, and we also can test things one-to-one on Earth. It's really hard to test something that's going to be landing on another planet because of the differences in gravity, because of the differences in the atmospheres.
So take a listen here again.
The team on the WB-57 doing
EDO milestone, we have touchdown. I repeat, EDO, FRC has touchdown.
And touchdown of the OSIRIS-REx sample return capsule. A journey of 1 billion miles to asteroid Bennu and back has come to an end, marking America's first sample return mission of its kind and opening a time capsule to our ancient solar system.
I loved Candace's reaction.
It's so cool!
Like a kid at Disney World.
Right?
There was
like
some
we
cheering.
Just got Mickey Mouse to land in Utah, right? Like,
right.
Ah!
Yeah, here's the team. Here's their reaction. And you can see the team celebrating. You guys were talking about all the people, all the jobs that go into this. And this is probably even just then a small sliver of the amount of people who went into making a mission possible. You can see their celebration. Again, this is a mission that has been underway since the launch in 2016. And truthfully, it's been underway longer than that because of the amount of planning and construction and manufacturing that had to go in prior to the actual launch. So now we will watch as crews move on out there to where the capsule touched down to begin its recovery. You can see those military aircraft still in the sky, the ones that have been providing us the live images. And now the ground crews will take vehicles out there to try to collect this. And then, Tony, if my memory serves, they will hoist it onto a helicopter, I believe you said, to get it to their clean room. Is that right?
That's correct. And I'm judging from where that helicopter is right now, and it's not moved a whole lot, so it's probably pretty close to the landing site. And comparing it to the FAA submitted plan on where that proposed capsule landing area is, they hit pretty close to the center of that landing area. I'm sure we'll get some numbers eventually that talk about how far off they were, but I'm guessing it's going to be measured not in miles, but in feet.
And you mentioned earlier in our stream this morning that this morning, over the course of the last few days, they had the opportunity to make just small adjustments to their trajectory in space. And it's just amazing. It's like the butterfly effect, if anybody remembers that movie, right? Where you make just one small minor adjustment and then downstream, it would make a huge difference on where this thing would touch down on planet Earth. And they did it.
And that's one of the things that amazes me most about. There's people in that room that we just saw celebrating that were in part responsible for all that planning and the numbers and figuring out the right trajectory for the parent spacecraft to take to be able to eject it, the ejection process to make sure that it had the right energy to put it into the right descent path. And they did a fantastic, absolutely fantastic job. But keep in mind too, that all that planning, it isn't just numbers that once you figure it out, that's the way it's going to go. There's variables that happen beyond there, not the least of which is our atmosphere. Our atmosphere is incredibly variable, not just the weather, but the upper parts of the atmosphere. It's very, very lumpy. So we just don't know where that thing is going to go until it goes. And that's why those landing areas are sometimes 50 miles across.
It looks like another helicopter now taking off. I presume this might be the actual helicopter that is going to pick up the sample We'll wait for it to show up on the flight tracking here in just a moment. While we do, it's 10:56 on this Sunday morning. I want to let viewers on WCNC Plus know that at the top of the hour, they will join Ben Thompson for this week's edition of Flashpoint. And if you want to continue streaming our coverage here of the return of the Bennu sample as part of the OSIRIS-REx mission, and you're on the WCNC Plus app, you can use your TV's remote control or your phone to opt in to watching this stream, which will continue on our secondary stream, Flashpoint, coming up at the top of the hour. We'll watch here, Tony, for that helicopter to appear on flight tracker. I can just only imagine maybe one is intended for, tracking visually, and then one's going to do the actual recovery, since NASA showed us that ground shot of that helicopter taking off. Candace, what have you observed here in the last few minutes that you know you're going to be sharing at the Shield Museum this afternoon?
One thing definitely is just the touchdown, and kind of like what Tony was saying, is like they hit that really close to, the bullseye that they were aiming for. So, kind of talking about that, and then really just talking about how the atmosphere does play a role. I think a lot of people don't really think about the atmosphere a whole lot in their day-to-day lives, but it really does make a difference. I mean, that's the reason we have meteorology and we talk about weather, is because of our atmosphere. And just showing, how this thing can travel, thousands upon hundreds of thousands of miles, but really like that last couple miles can make or break this mission, and it's all thanks to Earth's atmosphere.
And it's completely out of everybody's control too. So think about what it's like sitting in that room, watching this thing come back that you've invested, a decade of your or more of your career, and it's binary. It's either going to work or it isn't going to work. Thankfully, it's worked this time, and it's worked several other times ahead of time. But yeah, once it is ejected from the parent spacecraft, there's no controlling it. There's no joystick that can be used to guide it back into the right path. You're completely at the mercy of the planning to make sure that it is gone right, and to the atmospheric conditions at the time.
And I feel like, when you look at these videos here, like even like the one you're looking at now, it almost feels like a video game. But like you said, there's no joystick. There's nothing. You can't restart. Like, you're just watching, and it's just like, please work, please work.
We were just talking on the Carolina Weather Group podcast last week about how if you're controlling a rover on Mars or a satellite or a telescope in space, and that delay, and to your point, Tony, it takes a special personality, special characteristic to have that patience of left and then waiting minutes, days, almost years in some of these instances for those changes to be felt, and probably the anxiety of did I enter in enough? Did I enter in too little?
Yeah, and I think back to a toy I had as a kid called Big Track, and they actually reissued it. I bought my son one many years ago for Christmas one year, and it's very much like the way we drive the Mars rovers. You program in so many meters forward, turn so many degrees. That is exactly how things work with the Mars rovers. There's a planning meeting 3 times a week at the Jet Propulsion Laboratory for each one of those rovers, where the scientists sit down and they say, this is what we want to learn this week. This is the science we want to gather from these assets. And then the rover drivers, they're technically called rover planners or mission planners, they turn those scientific goals into movements for those robots, both with the wheels, driving them around, as well as using the robotic arms and things like that. But to your point, it's 15, 20-minute delay. So it's like a video game, but it's not, because you have to plan all these things ahead of time. Over the years, those robots have gotten more autonomous. They're making more decisions on their own. It allows us to get more science without that, waiting for data to come back and forth.
It's a great life lesson for kids and adults to have to think that far ahead on what the consequences of your action or your decision will be is pretty incredible. We're continuing to look live here in the room. The control for this amazing moment. I can see that somebody on the left-hand side is even holding up a microphone to capture the history and the science that is taking place in this room. We saw so many cheers. The actual sample is down there on the surface of Utah. You can see its orange and white parachute, which I have to imagine is no mistake to make it so detectable there against the surface. Tony, what was that mission a couple years ago that had like the binary? Do you remember this in the parachute? They had
very well
message.
Yeah. Perseverance.
Oh, that was Percy. Yeah.
Yeah, Percy, that was definitely a binary mission. I actually wrote I was so fascinated with that as a concept. I wrote a piece of software in Python that would allow you to arbitrarily create your own your own parachute, your Percy parachute, with whatever mission you wanted in there. And there was a Linux conference of all things in Italy that reached out to me and they said, "Can we use your software to create a Perseverance parachute to go on the side of the bags that we're handing out at the conference?" I said, "Yeah, only if you send me one of those goodie bags." So
There you go.
hanging up in here.
That sounds like
And
the
it
most Tony Rice thing I've ever heard, by the way.
and it did say "dare mighty things" in
It did.
binary code.
And the I forget it was the inner ring or the outer ring had the coordinates for JPL, but it wasn't just any coordinates. It was to the front door.
Very specific. We're waiting for the ground crews here to reach the sample, not only so they can recover it in a scientific, responsible amount of time to try to get it over to their clean room, but they also first will have to make sure that it's safe to collect. Listening into some of the NASA TV commentary, they want to make sure that it's in a condition where they can pick it up and move it safely here. And hopefully in the next few minutes, we will see some of those ground units we've been watching here on Flight Tracker. We are just again to the west of Salt Lake City. You can see out here at the Utah Test and Training Range some of these NASA aircraft, the military aircraft that have been providing the live video and will also be assisting in the recovery. Now, we did see a short time ago a second helicopter take off. I haven't quite actually seen that show up on Flight Tracker, but I don't know, Tony, you might know better than me. Not everything always shows up on Flight Tracker, depending, I guess, on whether or not its transponder is on.
Yeah, and if there's receivers in the area too together. Some of those receivers are sent up to satellite, some aren't. Also, helicopters, when they're very low, don't tend to send. And keep in mind, we're out in the middle of the desert here, so those choppers may be on the ground. Let me check another source for that. The one that I sent you is kind of an open sourcey one that
yeah, that's
I've
fair.
got a little Raspberry Pi sitting under my desk right now that's sending RDU traffic up to that site.
Oh, that's you.
Amongst many thousands of other people.
Yes. Yes, that's so true. Some of those flight tracker websites that are used and were really heavily used, as so many people know, over the course of the last week or so in South Carolina for the disappearance of that military aircraft are crowdsourced by people like Tony with antennas that are collecting the radio signals and sending them back up the internet.
All right, I'm going to send you another link.
Okay.
And it's got many more helicopters, actually. So stand by, and I will pop that in the chat.
So I don't know if we have any expectation on how long it will take them to get out there.
It should just be a couple of minutes. It's only the width of that landing area is only about 50 miles.
Tony's sent me another link here, another website. We can see that the helicopter continues to kind of orbit there out in that area. And, you know, it's moving at about 98 miles an hour. The particular helicopter I'm looking at here, Tony, has got an altitude of 4,700 feet. But the pictures we're seeing are from that much higher aircraft, if I recall correctly, right? That's
correct.
Yeah.
And it's still airborne. So I'm seeing 3 choppers out there, 2 NASA choppers, and it looks like a third-party one that's probably contracted. And where's the WB-57 right now? NASA 2, the Gulfstream is still out there. And it's just fun seeing this line of aircraft to the north that's heading into Salt Lake and departing aircraft out of the Salt Lake airport that's heading just about due south. That's continuing to happen.
Yeah, you know, they're trying to continue on with the commercial and public impact elements here. And really, you know, I guess because this is a military facility out there, this is probably something those air traffic controllers in Salt Lake City are fairly used to probably coordinating around.
Definitely. And there's a lot of good coordination between public aircraft control or flight controllers, such as those that are going to be in the Salt Lake Center, along with there's a couple of different airfields out there on those different proving grounds. There's really good coordination, especially when there's dangerous things that are going on to make sure that everybody stays safe. We don't have flights overflying the wrong place at the wrong time.
I couldn't help but think about before, as you were describing these aircraft, Tony, and how some of them are quite aged compared to what we might think about when we think about military or science missions, how it also reminds me of the planes that are used for the hurricane hunters, which are also quite of the older model and generation, and use the propeller planes in order to get through all of the precipitation and wind inside hurricanes. Is that kind of a common theme here on some of this, that they're using some of this older technology because it's better?
In some cases, yes. A jet aircraft flying through a lot of water is not great. Water ingestion in a jet engine doesn't work very well, whereas the propellers can power right through some of those really heavy rain conditions. But in large part, NASA's flying a lot of the hand-me-downs from the Air Force and from other places, and does a fantastic job of keeping them up to date. These are really flying platforms for the cameras that we're seeing off that WB-57, and for other instrumentation that is. These aircraft are built with very modular, very flexible ways of attaching all sorts of different instruments to do the kind of in situ study, mostly for atmospheric studies, but they're also used for situations like this where we're bringing spacecraft back in to study how that works and how successful we are in bringing these through the atmosphere.
Are in the area of the landing site and are in a search operation.
So you just heard that call out from Tim Preiser, who you see on your screen there from the mission operations room. He just announced that Helos 1 and 2 are now at that landing site. They're pointing out something on the screen. I see some smiles. It seems like we might have potentially some more information on that SRC in the coming moments.
Candace, let me ask you, this is a moment you've been waiting for years. I don't mean to rush you on to the next moment, but what's the next big thing in space you're looking forward to?
Oh my gosh. I mean, Artemis is always kind of like the next big thing I'm always kind of looking towards. But one thing I'm kind of like really excited about is the Da Vinci Plus mission.
What's
so I'm not sure if you've heard of that. It's going to be studying Venus. So taking a look at our sister planet, I mean, yeah, we know we can't really live on the surface of Venus, but, taking a look and seeing, because we call them the sister planets, we want to see, what made Venus so, why did it go so like left field from what Earth did? And just kind of learning a little bit more about our neighboring planet. So that one I think is set to launch in like 2029, if everything goes right. So it's still a little ways away, but I don't know, I'm kind of excited about that one. It's just really neat.
2029, here I am being impatient for Artemis, which is 2024, 2025. So that's interesting.
So one thing I wanted to say, because we keep talking about like how they're going to put these samples in like a clean room and stuff, and I think one of the benefits of the pandemic is now people kind of understand what that means. Right. So think about like, when you had to go to a doctor's office or, something like that during COVID, it was like, stand here, don't move, make sure you're masked up. I'm going to make sure I've got like all this protection on. That's exactly what they're going to be doing to this sample. They're going to be treating it the same way. They're going to be masked up. They're going to be like protective clothing. They're going to make sure that no surface, has any kind of germs on it. That way, when they bring this sample in, if they do find something that they didn't expect or something, we can say, okay, it wasn't from Earth. It wasn't because I sneezed and it got life on it. Or you know what I mean? Like, we're going to make sure that it's as organic as possible.
Yeah, sorry, I made the audio a little muddy there, but we were hearing on their radio communications that they do have visuals, and I apologize for cutting you off, Candace, but I think this is the closest shot of the thing we've seen yet. You can see it there, nose cone down, I believe, on the surface of Utah here, and this is another one of those orbiting views from a helicopter, Tony, that does appear to be fairly low, and hopefully we'll be looking at ground crews here in the next few minutes.
And look how nicely the capsule came down right next to a road.
That couldn't have been an accident.
I believe it was. But what's exciting about this is looking at it, it looks like it's intact. It looks like it's in one piece. So that's really, really important for all the reasons that were just mentioned. That's going to help ensure that those samples are kept pristine. And we know that we're looking at something from an asteroid and not something from the Utah desert.
I don't think there's any extraterrestrial life in the Utah desert. If not, that would be a whole different discovery here. But these are pretty incredible views we were getting. Again, we've been talking this hour about how remarkable it is that they got this to the right place on Earth. And now I'm thinking they even got it facing the right direction, if I'm not mistaken. That's the direction that should be landing, right? With that nose cone down following its descent through the atmosphere.
Yeah, that's really the only way it can land, because the drogue parachute and the main chutes are on the backside of that capsule, and that blunt nose shape to the front of that capsule is very much about helping it come through the atmosphere. That's where the heat shield is, and not only absorb some of that heat and peel some of that heat off as the bladed heat shield goes away, but also direct it away from the capsule. Again, to keep those samples as pristine as possible. And it looks like there's been some rain in the area. Maybe not super recently, but you can just kind of see where water is collected over time, and we see that sometimes. I was just out in the high desert of California a couple of weeks ago, out at one of NASA's communication facilities there. And it looks very much like this, with the scrub brush and those areas where water is collected. There's only a couple of dozen people that work out there, and they like to entertain themselves. This reminds me very much of the road that was leading out to one of the giant antennas that is used to bring back the data from OSIRIS-REx. Definitely used one of those antennas during its mission. But somebody got out of their car and had made a little plywood shark fin and stuck it out in the middle of one of those dry lake beds.
We can see a helicopter landing now. This is going to be some of the closest contact we've had with the sample. Tony is right. We did have some rain in recent days out there. Dry today, though. Let's listen in.
Landed at the recovery site.
All right, so the first helicopter is on the ground. Having a muddy surface out there is probably not the most ideal, but clearly good enough that they decided they were going to go ahead with the landing today. And having rain or mud out there would have made it even more difficult, but it seems like the helicopter was able to land just fine, and we'll watch them as they do their recovery operations here. If I'm not mistaken, if they had to do a go-around here, it's not like doing a go-around at RDU, Tony. This would have taken some time, I think, in order to orbit back around if the weather was no good today at the landing facility. But I think you also said they had backup facilities?
Yeah, there is no go around here. It's coming in hot, and it's going to land somewhere. So they would have chosen one of the other backup facilities, and that would have been when the mission planners would have really done their magic and repositioned that spacecraft so that when it ejected this capsule, it was ejecting it in the directions of New Mexico instead of Utah.
I got you. So I guess that would also have to mean that from a recovery standpoint, you've got not only land cleared out, but you have aviation units standing by to do exactly what we've been seeing here in Utah, but in New Mexico.
That's right, and they're using these military facilities in part because they've got the aviation facilities there where they can bring in these 3 helicopters, where they can bring in this high altitude aircraft and stage them ahead of the landing. The WB-57 has been up for several hours now, and is still flying, is still providing some support there. But yeah, they definitely use these wide open spaces because it gives us that nice safe buffer to be able to bring the spacecraft down.
Yeah, you mentioned the box that they were landing in earlier. It's about 36 miles by 8.5 miles here at the Department of Defense Utah Testing and Training Facility Ranch. Go ahead, Candace.
Oh, I just want to say, you're looking at this image right here, and you can tell that it landed in a gentle way, just because you don't see kind of like a skid into where it went. You don't see like a bounce, you don't see any kind of those things like if you were tossing a rock into dirt.
There's no debris, exactly.
Yeah. So, it was as gentle can be with a hurling spacecraft, but that's always a good sign. Like when I'm sitting here looking at this, I'm like, that makes me feel a little relieved,
It's a really good point.
Compared to go out tonight and look at the moon, and look at the south pole of the moon at the Tycho crater, and you'll see what are called rays. It's lines of debris that are hundreds and hundreds of miles long that still exist there today after an asteroid hit that part of the moon. That's not something we're seeing here. It probably came down at that couple of miles an hour that they were hoping for, which means the parachute absolutely did its job. And if you see the skid marks north of it, it looks like some vehicle ran off the road at some point in the past. So that kind of gives you an idea of how soft the soil there is. But this thing is sitting there, maybe depressed just a couple of inches. So it looks like it came down pretty gently.
I noticed those tire tracks in the background too, Tony, and obviously I have no idea what they're from, but it made me wonder if it could have been from any of the rehearsal periods, and if so, if this is the area that they were anticipating, like if that's just left over from rehearsals a week or so ago. I don't know. It just made me
Wouldn't
wonder.
That be cool?
Yeah. could be from anything. We're waiting for other crews to make their way out there to begin the recovery of these samples from the asteroid Bennu. And we saw one helicopter touch down. I'm not really sure where it went at this particular moment in time, but if I overheard commentary correctly a moment ago from NASA TV, other crews are not far behind. It's been on the ground now for about 25 minutes, if I were to round up, after coming into the Earth's atmosphere at 27,650 miles per hour. It did touch down here at about 10:55 a.m. Eastern time out here in Utah. And inside that capsule are some of the most sophisticated samples ever recovered from space. Just, and I say that politely, 8.8 ounces. But, Candace, I don't know if we've talked a whole lot during our broadcast today at exactly what they had to do to get those samples from a moving asteroid. That was quite the maneuver as well.
You are correct. It was crazy. So first off, Earth is moving. And so when we launch this, Earth is moving at the same time. Then you got this moving probe, the spacecraft that's going to a moving target. And then you're trying to boop it at the same time. And all this booping is happening while everything is moving. And then you also got to back off the asteroid because you don't want to be stuck on there. You also don't want to hit it too hard and then fly back and then be off your target. So lots of very critical moments to fire different engines to make sure that you are lined up just right. Kind of like what Tony was saying was, you have those certain movements that, okay, we need to be programmed to be, 3 degrees to the left. And, you hope that that's enough. And then, you got to come home and Earth's moving at the same time. Just lots of movement. Think about it kind of like kids running around on a playground, but they're running around in an organized pattern. And you've got to kind of, take a dodgeball and hit them, right? It's like playing dodgeball. Everybody's moving and you're hoping that you hit your target in the right spot.
Yeah, absolutely incredible. Hopefully you guys can hear me. My computer is frozen at the moment, and I'm working on bringing that back in. But it looks like we still have one of those helicopters on the ground and more on the way here for this recovery operation.
Can you imagine being in one of those vehicles and you're on the way there and it's like, do speed limits apply right now? Can we just get there? Teleportation would be the best thing at this particular moment in time because you know how anxious they are to be like, come on, we got to make it.
That thought crossed my mind too, because every time on a military base, I am on my extra best driver behavior and driving absolutely the speed limit, because absolutely the last thing you want to do is talk to this military police. But certainly these aircraft can do pretty much what they want within safety, and then whatever ground support vehicles will show up there. And I don't know that they're going to send any ground support vehicles out there. This is probably all going to be handled by those helicopters. They're probably moving as quickly as they can, but as safely as they can. They've got time. This is actually not going to be returned back to the Johnson Space Center until tomorrow. They'll have some time to safe the capsule, because this isn't just a go pick it up and carry it off. There are explosives on board. There are explosives that are involved in deploying the parachutes. There's 2 parachutes. There's a drogue parachute that helps pull out the main parachute. So we need to make sure that those are safe. The last thing you want to do is bring a live ordnance aboard a helicopter until it has been saved.
I feel like this is the equivalent of you've ate your entire plate of food and now it's time for dessert. And then mom's like, hang on, we need to be patient. And you're like, But I just want to eat it now.
It's right there.
It's right here.
Oh, here we go. We got some ground crews on foot here.
Yay.
So they're both wearing personal protective equipment. We were talking about the safety not only from the human perspective, protecting us from the craft, but also protecting the craft from us, as we don't want to make any contaminants here. So we got 2 individuals on the ground here approaching the samples.
Yep, they're looking for that ordnance.
In fact, doing that survey right now.
And look how small that craft is. I mean, I'm sure that's like an average size person, and it's so tiny when you think about it. And we made that little tiny thing work.
Yep, so 3 feet across. So think of a snow dish. Think of the dishes that you ride down a snowy hill on. It's about that size.
I don't want to derail us, but I've never heard them referred to as snow dishes.
Me neither.
What do you call it?
So you're not talking about the sled. You're talking about the actual circular ones.
Like the circular
ones, yeah. Yep, it's about that size.
Now I'm being put on the spot. What would I call them?
We don't get enough snow around here to
It'll
know.
come back to me later. Although I will say that as a kid, I always had the plastic ones. And I guess the ones previous to that would have been the ones with the big metal tracks on them. But the newest ones that I really love, because you just float atop the snow, are the ones that look like boogie boards. And it's just like the styrofoam or something.
I've done the pizza pan before.
That's very southern of you.
Yes.
They're checking the thermal temperature right now of our capsule. Go ahead, Tony.
In college, we did the trays from the dining hall.
Yeah, that's classic. That's classic.
It's
I could have made
being
so much money.
resourceful.
One semester, I drove back through snow. I was coming from New York to Georgia, and mind you, we hit the snow in South Carolina. That was a weird experience. And then the University of Georgia was closed for like a week because of a couple inches. But had I had any foresight to take the New York sleds and put them in the car, I could have made so much money on campus. So it's relatively quiet right now on our NASA feed in my headset as we are waiting. They are checking the safety of the capsule, including checking the thermal temperature of the capsule. And then they're going to eventually hoist this bad boy away on helicopter.
As opposed to the other kind of temperature?
Yeah, you're right. As opposed to the other type of temperatures. Thank you for noticing that. As soon as it came out of my mouth, I went, that was redundant.
But they're likely using some of the same kind of equipment. You know, maybe a chef would use a contactless thermometer, infrared thermometer. They can just aim the gun at it, and it tells you what the surface temperature is.
Yeah, let's take a look here.
Notice when they walked up to it, the last thing they would do is...
So Stu is going to get that parachute stowed.
Yeah, that belongs in a museum. Let's save that parachute.
Yeah.
They're probably going to do some study of it, though, to see how it fared, if there's any improvements that could be made to future parachutes.
In case of anybody of importance is watching this, the Show Museum would love to put that on collection.
Yeah, we'll just send it out here. Is that a thumbs up? I'm hoping that was a thumbs up.
Oh, they approved.
Yeah. All right, we'll watch here. You can see in the corner, mission control, aerial images on the top right, live from, I'm just going to say, the desert of Utah. I will point out, not to embarrass her, but the sound of a bird is coming from Gastonia and not Utah.
Yes, sorry about that. I'm enjoying nature today.
It's a lovely backdrop there.
Thank you.
And the birds have shown up now for excitement here of the sample from the Bennu asteroid. So far, I've only seen two human beings out there, but you can see the number of human beings, the support staff, and all those who have made the mission possible glued to the same images we're glued to. Although they're actually staring at themselves, it looks like, on that TV, so that's a little uncomfortable.
I assume that they probably don't want to have more than necessary out there just because, you don't want that risk of contamination. So the less people you have, the less risk of contamination. So they probably just have, the bare minimum that they need to get the job done.
You were talking before, Candace, about the lack of impact on the desert. And I think the same can preliminarily be said about the capsule itself. The capsule itself also looks like it's in, as best as we can tell, one solid piece.
Mm-hmm. Yeah, like Tony was saying, you don't see the debris or, anything that looks abnormal around it. So wonderful job to the team that helped with the parachutes and the descent, because it obviously worked.
All right, so now we see this crew member attaching something to the capsule. And eventually here, we're going to have to start to see the installation of however it is they plan to hoist this thing. Whether that's what's happening now or not, I couldn't say for sure. They keep referring to the individual in the white shirt as Stu. I don't know if that's his name, like Stuart, or if it's some sort of mission title. Do you have any insight on that, Tony?
I really don't. They don't tend to refer to people by their first name, so
I know, that's what I was thinking.
Maybe it's like Special Transport Unit.
Oh, yeah.
I don't know. I'm making that up. But
I'm guessing
really good
sample
with acronyms.
Might be the S.
And I don't know the name. I believe this is the individual closest here. I believe this is a woman who I think we just saw take a picture of the capsule. I was watching kind of their dress. Not only are they dressed in personal protective equipment for the mission purposes, but the latest weather observation now at Salt Lake City, the nearest international airport, 57 degrees and clear. Winds continuing out of the southeast at 6 miles an hour and 52% humidity. Although I think probably the most important thing is that 10-mile visibility. You couldn't ask for more visibility.
All right, we were talking about how NASA loves acronyms. So this mission was called OSIRIS-REx, and I love the naming of this because it's just a mouthful, but it stands for Origin, Spectral Interpretation, Resource Identification, Security Regolith Explorer. Say that 3 times fast.
I cannot. I'm impressed that you knew that, and at the same time, not surprised that you knew that.
I'm a nerd, right?
Do either one of you guys have any indication on how soon this thing might get hoisted up? Do we sit here and wait for it, or is this something that's going to take quite an extended period of time? Does anyone know? As we continue to look at, a ground shot.
Oh, yes.
So maybe one of the things I was getting attached is this. Are we looking from the perspective of the capsule? That would be crazy, right?
Now the capsule's there in the background. You can see it. This is probably from
the helicopter.
One of the aircraft landed. Yeah, because they're heading back that direction.
That makes a lot more
sense. I find it interesting that there is some equipment in the background. Don't know if that was staged there purposely for this mission, or if this is an active military installation. So
yeah,
who knows what's out there.
Let's take a listen into this report.
We're so grateful that the capsule is on the ground and in good hands now. Now, from here, from Wig Mountain, I am overlooking the vast landing zone, which, again, is larger than the state of Rhode Island. So, during that time, listening to James's commentary of the capsule coming through our atmosphere, we're all standing on the edge here, looking and scanning through the sky. But just to give you some context again of where I am, I'm about 4,000 feet up, overlooking a vast ancient seabed. So the mountains that are peppering along the edges over here, they are very muted colors. It's a beautiful pastel out there. And as we're looking over through the sky, it's hard to see because there's alkaline dust from this ancient seabed. And considering that the capsule has landed on the edge of the landing zone, even though I'm as close as I could possibly be, I didn't see anything over here. I will say I'm a little disappointed, but grateful that that capsule is in the most capable hands it can be, and that is the most important thing out here. So while I didn't see with my eyes myself, we saw it on the screen, and it's still a great day. So back to you, Lauren.
Wow, thank you, Sophia. And thankfully we got that great image from the NASA helicopter. Just well done to that.
Tony, right before we went into that live report, you were noting the same thing I had noted there at the last minute, which was that they seem to have some structures that I hadn't noticed from this orbiting view out there at that military test facility. What they might be, I don't know. They looked like containers of some sort, but we saw them from that ground shot. So there they are again, right on cue. So they do, in fact, look like maybe some like a container you'd almost see in the back of a freight train or a freight truck, and then some sort of red and white structure.
Containers are used a lot on these military installations for storage and other things. That the standardized shipping container was actually invented in North Carolina. Did you know that?
I did not know that, and I consider myself such a rail fan nerd. Oh man,
get the
totally using that today.
Get the up to the Museum of Transportation in Spencer.
Oh yes, I have
some information on that.
I have my membership card actually right here in front of me, but it's got way too much information on it for me to hold up. We're getting now a statement from Bill Nelson, the administrator at NASA. Let's take a listen.
Someone who keeps a close eye on the entire manifest of the space agency's travels around the solar system.
Hey everybody, congratulations to the OSIRIS-REx team. You did it. You designed it. You built it. And you carried out the first mission to collect a sample from an asteroid. And after a 2-year journey, it has touched down at the Utah desert. It brought something extraordinary, the largest asteroid sample ever received on Earth. It's going to help scientists investigate planet formation. It's going to improve our understanding of asteroids that could possibly impact the Earth, and it'll deepen our understanding of the origin of our solar system and its formation. This mission proves that NASA does big things, things that inspire us, things that unite us.
Recovery operations, we can confirm that the SRC is not breached.
Beyond our reach. And the mission continues with incredible science and analysis going to come. But I want to thank you all for everybody that made this OSIRIS-REx mission possible. It wasn't mission impossible. It was the impossible became possible. Thank you all.
And just as a reminder, we are keeping those operational milestones going, so you will continue to hear that throughout the broadcast. Thankfully, the SRC was not breached. Fantastic, fantastic news. All right, as anyone...
That was the answer to, we didn't cut the boss audio off. It was the radio started talking at the same time. We can see additional personnel have now arrived out there at the site where the sample did come on down. And you can even see that I think they've got a camera set up on a tripod. Speaking of pictures, Tony, you've just sent me, oh, I get my mouse back. You've just sent me a picture of, is this the actual clean room they'll be using?
That is the actual clean room. And you can see in this image the holes in the side. Those are where gloves are attached to be able to reach inside of this containment unit. So the whole room itself is a clean room, but this is called a hyper clean room. And the samples will be living inside of those spaces. Some of them will be extracted for other uses, but they're going to keep them as isolated from the outside environment as possible.
Yeah, it's like it's a clean room inside of a clean room almost.
It is.
Yeah, I mean, I can understand all the precautions you certainly want to take. As we've been mentioning, this mission years in the making, and you would want to take any precaution you can against potential contamination as we continue to look at these live pictures here from Utah, the capsule out there. You know, I guess I can say, Tony, I wasn't sure exactly how quickly they would be trying to recover this to reduce the risk of contamination. Obviously, they've looked over the capsule to try to determine whether or not it's all safe and still intact and able to be moved. But I guess what I'm in my own personal thought, I envision this thing being hoisted away by now to that clean room facility, and it's still out there on the desert floor.
Yeah, I think it's going to be a little while. So us actually seeing it, being picked up and carried away, that might take a little bit of time. There's a lot of data collection. There's a lot of safing that still needs to go on. And again, they're not in a huge rush because this doesn't need to be in Houston until tomorrow.
Yeah. I think what we might do here in a few minutes is leave our viewers with these live pictures from NASA, depending on how long this is going to continue to play out for, and provide them updates on the mission. As Tony just mentioned, there are going to be future milestones here of bringing this back to Houston and then eventually opening up the samples. And, NASA will be holding many media events to try to excite the public about what it is they recovered. We'll hang on here another moment longer as we can see now several people approaching the sample. And this is one of the closest ground shots we've had yet. I don't know if maybe this is the camera we saw on that tripod, because you can actually see here. Yeah, you can actually see the faces of the people who are approaching the capsule.
This is great too, because take a look at that capsule and its color. It was originally kind of an off-white, but you can see the environment that it went through, that incredible heating that it went through as it was going through the atmosphere. It's turned a nice charcoal brown, charcoal black.
Yeah, but it has done its job, right? It kept the capsule intact. Those heat tiles, pretty incredible. I remember, as I mentioned earlier, having recently gone to Kennedy Space Center, both for a NASA social event and then later in the summer for a visit to the visitor complex. When you go and see the space shuttle, for instance, up close, and you can see those individual tiles, it's amazing the work that those tiles do. And here's that shot again, Tony, or not.
Yeah, if you ever make it up to Hampton, to the Virginia Air and Space Museum up there, that's the official visitor center for the Langley Research Center, there is an Apollo spacecraft, and you can look underside at that ablative heat shield and see how much of it has been torn away, and you can see the residue of the heat that it was exposed to as it was coming back through the atmosphere. So seeing those real things is really, really important.
We can see they're taking some more pictures that I imagine will be released to the public here shortly, close up of this capsule, which so far has seemed to gone as best as we can indicate, just as well as their rehearsals have out there at the Utah training facility to the west of Salt Lake City. And we're going to leave you here, I think, with these live pictures, Tony, as maybe we'll step away as we continue to watch the scientists with their recovery operation of this capsule. Again, 8.8 ounces, 250 grams, following a launch that happened in 2016, a collection that happened in a very chaotic and busy year of 2020, a year that actually had so many space milestones happen, and then has been flying its way back to Earth ever since 2021. Tony Rice, NASA ambassador in the greater Raleigh area. Any closing thoughts for us?
One more number to throw out there. The mission goal as far as sample collection was a little over 2 ounces. So definitely outperformed with 8.8. They did a nice job there. And the last thing I'll leave you with is, are you ready for what will be a partial eclipse here in North Carolina coming up in mid-October?
Tell us about that real briefly. This is the Ring of Fire eclipse, if I remember correctly.
This is an annular eclipse. We've got 2 eclipses coming up here in the next couple of months. The first is October 14th. It is an annular eclipse, and annular in this context does not mean yearly. The annular is from the word annulus, meaning ring. These are eclipses that occur when the moon is a little bit further away. Sometimes the moon's closer, sometimes it's farther away. When an eclipse occurs at that, close to that apogee point where it's farther away, we get an annular eclipse. So the path of annularity, which is the annular version of totality, or the path of totality, is going to run from Oregon down through Texas. Now here in the Carolinas, we're going to see a partial eclipse. And it's going to be a pretty good one. I'm going to send you more information than you ever wanted to see on this eclipse and also the history of eclipses in North Carolina. So look for that in the coming week. I'm finishing up the code for that today, as a matter of fact. But that's the first of a couple, or first of 2. The next one that's coming up will also be a partial eclipse for us here in the Carolinas, but is a little more accessible because it's going to be running up through Mexico, come through Texas. Texas gets double duty here. They're the lucky ones over the next year. It'll go up through Texas, through the Ohio Valley, out through Maine and the Canadian Maritimes. That's going to be a total eclipse. So if you think back to the 2017 eclipse and how absolutely incredible that was, I know a lot of people were really hooked on it and are interested in seeing the total eclipse that's coming up here in April. You're gonna have to travel a little bit. I personally will be going to Texas, mostly because of weather reasons. I think our chances of not having clouds to deal with are a little bit better there. The further north you go there, the more you're gonna have to deal with clouds. But again, it will be visible here in North and South Carolina. If you have not already found your eclipse glasses from back in 2017, now's a good time to look for them. If you can't find them, go ahead and order some. It may be too late. I don't know. I've not checked lately, but it's going to get the eclipse fever is going to be pitching up here in the next couple of weeks. So think about getting that. And there's many other ways that you can view the eclipse. I'll send you some information on that too. One of my favorites is making one out of a eclipse viewer out of a cereal box with just a little bit of paper and some tinfoil to make that little tiny pinhole that you need to create what is essentially a camera obscura, the same way your camera works, to shine that eclipse down on the bottom of the cereal box so you can look at it very, very safely, and just recycling something that you already got in the house.
Pull the curtain back. Tony Rice is the brainchild of so many of the fun tidbits we bring you on WCNC.com and the Carolina Weather Group. They tend to come over from Tony. And Tony, you maybe have noticed their renewed interest lately back in the what I like to call the space train. Some people call the satellite train of the Starlink, SpaceX. I think people still discovering these things for the first time, and we've seen some renewed excitement around that lately, and that's been fun to see too.
Yeah, I've been working with you, and pull the curtain back a little bit more. You're one of close to 400 meteorologists I work with around the country, and it's exciting to do it. And I'm so thankful that you guys will bring this stuff out there and make people aware of it, and just get people outside looking up. I think I've got you all trained to the point now where I don't get the question about what were those 8, 6, 12 dots that I saw in the sky. You know that they're Starlinks, and I've actually got you looking for them now. They're really cool to see.
They are really cool to see indeed. And on that note, you may have noticed that we've taken away our live aerial feed, and I think that's because it is returning for fuel. So that might make a very natural transition point for us here. To wrap up our coverage this morning, we did just get back into our control room, that ground shot that Tony was looking at a short time ago, and you can see the scientists out there. And I think that's probably what we'll leave streaming here for you as we anticipate them to continue examining this capsule before taking it to the clean room facility they have set out there in Utah and ahead of its transport to Houston. So, Tony, I appreciate your time this morning, and always so many great insights.
Anytime.
And on behalf of Tony and Brittany Van Voorhees and Candace Jordan, I'm James Brierton. Thanks for joining us for this special coverage of the return of the asteroid samples as part of the great multi-year mission that has been playing out here. And we have so many more to come with Artemis and crude missions to the International Space Station. If you like weather science and technology, then like and subscribe wherever you're watching us this morning, because we'll keep you posted. That does it. Enjoy the rest of your weekend. We'll talk to you again real soon. Bye-bye now.
to this moment that we have today.
And Mackenzie, we have leadership across all domains on this mission, from system engineering to science to accounting to everything. How did your team in Maryland pull this thing off?
You know, we have people who have managed multiple parts of missions over the decades. Systems engineering is critical, and it's one of the things that Goddard really brings to the table. And systems engineering means that we take into account everything about the mission, from the science ideas to the launch to orchestrating the landing here on Earth, but making sure that all of the instruments are working together, making sure that the spacecraft successfully interfaces with the instruments and can carry out its job once it is at Bennu. All of that requires really understanding the entire system. So when we say systems engineering, we're really talking about that overarching, holistic perspective that our scientists and our engineers bring to the table. But it's true that we have some of the greatest scientists and engineers working on space missions, and they pull it off every time.
Awesome.
Fantastic. Well, you know, really quickly here, Goddard will be one of the centers that will receive a sample, but who else will receive a sample of the asteroid?
Samples are really traveling all around the world. What I think is very exciting about this mission is
Fabulous. Still moving. BGM copy.
Sam Richard online.
This is Sam, go ahead.
Yeah, I just wanted to check, is the cargo net all set up so as soon as they drop it in there, you guys can skedaddle out?
Cargo net is ready.
And is the science team?
Cargo net all set up so as soon as they drop it in there, you guys can skedaddle out. Cargo net is ready. And is the science team going to need to stay in the fuels, or will they be returning with the other heroes? Well, it's hard to tell. We will not return at the same time. They will be after lunch. Thank you. Let's get some back to go. You went by 2 minutes.
Live, yeah, the live stream show. Fine.
Boy, it's really hard not to get a little emotional when you see all those faces. These are a lot of the people that we've been seeing over the last few days, and they're getting their time in the sun. All right, let's throw it over to James for an operational update. Take it away, James.
Yeah, thanks, Lauren. So while we've been kind of waiting for the past couple of minutes here, the team has actually successfully bagged and prepared the sample return capsule for the long line operations. You can see on your screen right now, the SRC is bagged within thermal blanketing, and that metal thing you see on the bottom is the carrying fixture. This will then be actually loaded up into cargo netting and prepared for long line operations. One of our helicopters will take flight, carrying the SRC dangling beneath it. The SRC is going to be stabilized with that cargo netting. There is a gimbal that will keep it stable as we begin the flight to the clean room with our precious cargo on board. You'll notice a couple of tape markers on that SRC as well, the thermal blanketing there. Those are pieces of Kapton tape marking exactly where vents are on that SRC for team members here at the clean room, who will once again do gas and thermal readings once it arrives at the clean room. Just once again making sure team members are safe and secure as we begin to continue those recovery operations, getting the SRC into the clean room. And this is one of the last phases of the process of getting our SRC back and then opening it up, finally seeing that sample canister within, and preparing that for shipment tomorrow on the C-17 cargo plane to the Johnson Space Center's sample curation facility. And this was a very quick process. I mean, if you're keeping time at home, this was only maybe about 20 minutes that they took to get out there once they arrived and wrap everything up really quickly once they were given the official confirmation to approach, get everything stored, prepared for those long line operations. This really has become second nature for these team members. They really are able to bag and prepare this SRC, and you'll see still quite a few flags around that area there. Once this SRC is flown away from the region, the landing zone, team members from the curation team will remain on site and continue to take samples of that surrounding area. They also have set up off screen here, you can't see it, but there is a air reading that they're going to be taking actual air samples of the area, atmospheric samples. All of this will be cross-correlated with samples that we actually get back from the asteroid Bennu to make sure that nothing from Earth here at the LZ or beyond got into that sample return capsule. And you can see some of those team members who are going to be taking those samples, once again approaching the location. Dante Loretta is front and center with them. He has that armband on, and on his left arm, you can see it there, as he's carrying his bucket that has all of his tools that he needs to begin collecting these samples. It's a very tight procedure that they have to go through to make sure that they are properly taking these samples. You can see they are photographing the area first, documenting exactly where they are collecting the sample from. They then have a small metal scooper that they'll use to actually dig into the desert surface. A bit of a soft surface out there today. As I mentioned, we did have some rain that softened it up, so it should be easy to dig in there, grab a bit of sample, and then they will bag that sample, seal it up, and then send that off to the sample curation team at the Johnson Space Center. Admiring the region as well. It's a beautiful, clear morning there today. We've been rehearsing in a variety of different conditions, including in the middle of the summer where temperatures were over 100 degrees Fahrenheit, much cooler conditions. You can see our team members wearing their UV shirts today. A much chillier morning for them as they are doing these recovery operations. And this process does take some time as they go through and collect these samples. They want to make sure that they are accurately documenting exactly what's present at this landing zone for the team members who are at the sample curation facility of the Johnson Space Center.
got to pull my computer. If anyone else wants to plug in, there's an HDMI cable here.
Hey Richard, can we go over quick real time before you book? We think helicopter 3 is going to get here at 10. It'll be, if it's 5 minutes early, it'll be here at 10:25.
Yep.
So within 10 minutes?
Yeah, within 10 minutes, yeah.
Okay.
You must be so excited to dig into the sample yourself. But what makes this sample, you know, we've continued to say this is such an important sample from an asteroid. Why is it scientifically?
So Bennu is an ancient piece of the overshield system, a leftover component. It's a fragment of what happens when you make planets. And this fragment of rock it contains the ingredients that happen when you make planets, that happens when you make life. So by studying a sample from leftovers of space, you can study a sample from the leftovers of the formation of the Earth. Look at the chemistry in detail that you can only do on the ground using instruments that are